Hi everyone, welcome to the channel. So today we're going to solve one more problem from LeetCode, that is 39th problem, combination sum. In this problem we are given one array of distinct integer and then target. Then what we need to return? We return all the list of all unique combinations of candidate where the chosen number sum to the target. Let's take an example over here. So this is the array, right? 2 3 6 7, and the target is 7. Now if you add 2 plus 2 plus 3, that will equals to 7, right? So that is the one combination. Now the second combination will be itself 7, right? 7 is equal to 7. The constraint we are given is that the same number we can use unlimited number of times, right? That is the constraint. So anywhere we see these kind of problems, like to find the combination sums, obviously we're going to use the recursion. Let's try to understand in one note. Okay, I have written one array that is 2 2 3 6 7, and the target is 7. So let's draw one function. From that function we can understand how recursion will work over here. So basically, and then we'll put index and then target, and then we'll carry one data structures. Basically, in this data structure it can be list. We'll keep on storing the elements whose sum is equal to target. Now basically everything is empty, data structure is empty, and then we are starting from 0th index. Now from this index we will be having two possibility, whether we can pick this 0 and we cannot pick this 0. If we pick this 0, that means we are including the, let me write the index over there, we are including the 0th index. Then it will be, then if we include 0th index, that will be 7 minus 2, that will be 5, and then in our data structure we are including 2, right? And if we won't include 0th index, then it will be our first index, data structure will be same, and then basic target will be same, and data structure is empty, right? Again over here we will be having two condition, whether to pick 0th index or not pick. So let's say we pick 0th index. In this case it will be having 0, 5 minus 2, because again 2 is coming from here, 2 is coming from here. So 5 minus 2, that will be 3, and our data structure will look like this, 2 2, right? And let's say if we won't pick it, then it will be 1, and then here we picked 0, right? And here we, then it will be 5, and then the register will be same 2, right? Now again over here we will be having two possibilities, right? Whether to pick it or not pick it. If we pick it, then it will come like this, 0, then 3 minus 2 is 1, and then data structure will look like this, 2 2 2, right? And if we won't pick it, then it will be something like this. It will be first index, then 3, then same, 2 2, right? You notice something, right? Once we reach to this end, then our target is 1. That is basically less than our 0th index element, right? 2. In this condition, what we will do, we'll stop our recursion, right? Over here we will stop our recursion, and then we'll see whether this target is, whether this target becomes 0. If no, then what we can say, this 2 2 2 is not our answer, right? So what we'll do, we'll just backtrack from here. This is the recursion, right? We'll just backtrack from here, and then from here we'll try to explore this thing, right? Now let me, so from here what we can do, we can pick the first index, and we can't pick the first index, right? If we pick the first index, then again this 3 minus 3, because this time 3 is coming, right? At first index, what is the value at first? And the first index, the value is 3, right? Now if 3 minus 3 is 0, and then data structure will look like this, 2 2 and 3, right? But over here when we backtracked it, what we need to do, we need to remove this upper element, right, which we have added. So that is the main part, right? Every time we just need to, every time when we are backtracking it, we are removing the element which we added, and then we are keep on exploring the right part, right? So in this case that is 0, right? So we will stop our search from here, and then we will return 2 2 3, right? So that is basically the answer. So let's see in a code. Okay, so yeah, I have written the code and then submitted it as well. It got passed. Let me copy this code in OneNote and then let's understand over there. So I pasted the code in OneNote. Let's understand how it is working. So this was our main function, right? Up to here. So this was our main function. Basically, we have created one list of integer, and then that is kind of array list, and then we are returning it. There is one more function that we created, that is combination sum. So this was the function. So this is the base condition. Let's understand the recursive call first. So in recursive call, basically we are checking the each and every index if we are picking it. So this is for we are picking it. Then what we are doing, we are adding in a data structure. So this line you can comment. This is just I'm printing it. So we are adding this is in our data structure, and then we are keep on calling the left function where our index will be same. It means we are picking it, and then array will be same, and then the target will reduce from target minus current index value, and then answer and ds will be same. Once we done this the full left part, then once we backtrack, in backtrack we discussed like we need to remove the value, right? So we need to remove the value. We backtrack and then we'll go to the right right part whether we won't pick that element. With this function also again we'll keep on go to the left. So this is the thing that that is going to help us. This function is basically will help us to doing this. Now coming to this criteria, over here we are checking that we have traversed each index where index equals to array of length. So we traverse each index, and then whenever our target is 0, remember whenever our target was 0, then we are storing it in our answer array. If not, then we are just returning it. So yeah, I hope you understood the problem. Thank you.